So we've talked a little bit about complex numbers in a previous lesson, and that's where you have the imaginary number. And so now we're going to look at the trig form of complex numbers. And so we have something called the complex plane, and that's basically a coordinate plane where you can graph complex numbers. And so if we have a complex number that's a plus bi, then a is your x value, so your x-axis is the real numbers. But then your y-axis is the imaginary axis. And so the bi part of your complex number tells you where to graph that. And so you're taking the b part of the number and graphing that along what would be the y-axis, but now it's an imaginary axis. And so you can see on the diagram that the point, or the imaginary number, -1 plus 3i becomes the point -1, 3. And then 3 plus 2i becomes 3, 2. And -2 minus i becomes -2, -1. Okay? So we can find the absolute value of a complex number by basically finding what we think of as the r, so the square root of the a squared plus the b squared. And so that's how we can find the absolute value of that complex number. So for number 1, we're just plotting this number, -6 or -8i, okay? And so we just take the -6, -8, so we come to the left on the x-axis about 6 units, and then down about 8. And so that is our point, -6, -8. Fairly simple. And now we're going to try to find the absolute value. So we've got -6 minus 8i. And so we're going to take the square root of that -6 squared plus the -8 squared. And so we end up with 36 plus 64, which gives us the square root of 100, which is 10. So the absolute value of that complex number is 10. All right, so now we're going to take a look at the trig form of complex numbers. And so you can see in the diagram we have this angle. Remember that we have the initial side that's rotating to land at the terminal side, and we have a right triangle that is formed from that. And so this is why the trig is important. So we can see that if you have a complex number, a plus bi, you can rewrite that as r, which is that length of that side, or the hypotenuse, if you will, times the cosine of the angle plus I times the sine of the angle. And then you also have a few other little formulas that might help you out. A is equal to r cosine of theta, b is equal to r sine theta. Again, r was the square root of a squared plus b squared. And then remember that tangent is b over a. Okay, and so the number r is the modulus of z, and theta is called the argument. So those are just some new terminology for you. All right, so we want to write this complex number, z equals -7i in trig form. And so we can find our modulus. That's the square root. Now we don't have an a, so that's 0, plus b squared, so -7 squared. And so that's going to give us the square root of not 7. So that's going to give us the square root of 49, which is 7. So our r is 7. And since we had 0 as our x value, and we had -7 as our y value, then you could look at the tangent of theta is -7 over 0, which we know is undefined, and so it would have to land at 3 pi over 2, because that's where you have 0 as your x value on that y-axis, and because the 7 is negative, it has to be down at 3 pi over 2, not pi over 2. And so we know that our angle measure is 3 pi over 2. So now we can find the trig form. Okay, and so that just becomes 7 times the cosine of 3 pi over 2 plus I sine of 3 pi over 2. And that is the trig form of negative 7I. All right, let's try another one. All right, so this time we have negative 2 minus 2 square root of 3I. And if I graph this, I know I'm going to be over here in the third quadrant. So that's negative 2 square root of 3. Okay, so we know we're in the third quadrant. That's going to help us with our angle measure. Let's find our modulus. So we've got square root of negative 2 squared plus negative 2 square root of 3 squared. Okay, so that becomes 4. And then when we square that other negative 2, we get 4. When we square the square root of 3, we get 3. So 4 times 3 gives us 12. And so that becomes the square root of 16, which is 4. Now, we know that the tangent of our angle measure, or our argument, is negative 2 square root of 3 over negative 2, which is just square root of 3. And so we're looking in that third quadrant, where is tangent equal to the square root of 3? And that would be at 4 pi over 3. And so now we can just put the pieces together. So z equals r, the argument, the modulus, times the cosine of the argument, so 4 pi over 3, plus I sine of the argument, so 4 pi over 3. And that is the trig form of negative 2 minus 2 square root of 3. All right, so now let's try going from the trig form back into standard form. So we know that our r is 5, and so we can find our a value. Remember that a was equal to r times the cosine of theta. So a is going to equal 5 times the cosine of 7 pi over 6. Okay, and the cosine of that is negative square root of 3 over 2. And then we can find b. And really all we're doing is distributing this 5. And so b is going to be r sine of theta. So that's 5 times the sine of 7 pi over 6, which gives us 5 times negative 1/2. And so we can put the pieces together. So our complex number becomes negative 5 square root of 3 over 2 minus, because that's a negative 1/2, 5 halves I. And that is the standard form of our complex number. All right, so now we can take a look at the product and the quotient of two complex numbers. And so we have this formula that we can use to make it a little bit easier. And so we're going to find the product. So the product of z sub 1 and z sub 2 is r sub 1, which was 7, times r sub 2, which is 3, times the cosine of the sum of the angles, so that's 3 pi over 2 plus pi over 2, plus I times the sine of the sum of those angles. And so we can multiply the 7 times 3 to get 21, and then we have cosine of 2 pi plus I sine of 2 pi. And then we can simplify that even further. Cosine of 2 pi is 1, and the sine of 2 pi is 0. So we end up with 21 as our answer. All right, let's take a look at another product. So we have z sub 1 times z sub 2. So we're going to multiply 10 times 6. And then we have cosine of the sum of the two angles. So that's going to give us 18 pi over 12 plus I times the sum again. So that's 18 pi over 12. So 10 times 6 gives us 60 times cosine. And that's going to simplify to 3 pi over 2. That'll just make it a little bit easier for us to figure out what those values are. And so the cosine of 3 pi over 2 is 0, and the sine of 3 pi over 2 is -1. And so we end up with -60i. Now let's take a look at a quotient. Okay, so we're going to use our quotient formula. And so we're plugging in our R values. And now we're going to subtract our angle measures. So we have cosine of 70 minus 25 degrees times I sine of 70 degrees minus 25 degrees. And so that becomes 4 times the cosine of 45 degrees plus I sine of 45 degrees. So we get 4 times the square root of 2 over 2 plus, we'll put that I in the after part. Okay, so square root of 2 over 2 times I. And then when we multiply that through, we end up with 2 square root of 2 plus 2 square root of 2i. And that's how we can find the quotient. All right, so the next thing we're going to do is determine what 1 plus I to the 6th is. Now we could expand this by multiplying it all out, but we really don't need to do that. There's a simpler way. Okay, so the first thing we can do is find our R value. And that's just going to be 1 squared plus 1 squared. So that's just the square root of 2. We can find our angle measure, or the argument, and that is the arctangent, or that tan to the -1, or not tan to the -1, the inverse tangent, and that is not a -1. So we can find the inverse tangent, or arctangent, of 1, and so our angle measure is going to be pi over 4, because we had a +1 and a +1, so we know we're in quadrant 2, and the tangent value of 1 is at the angle pi over 4. All right, so now we can use this formula up here to figure out what z to the 6th is going to be. So we have R, which was square root of 2, to the 6th power. So I'm going to raise that to the 6th power. And then we're going to multiply by the cosine of 6 times pi over 4, so that gives us 6 pi over 4, plus I sine of 6, which was our n value, times pi over 4, so that's 6 pi over 4. Okay, and then this becomes, remember that square root of 2 is really 2 to the 1/2, so I'm going to write that there for you in case you don't remember. And then this becomes cosine of 3 pi over 2, because we can simplify that a little bit. And that'll just make it a little bit easier when we look at our unit circle. All right, and then that becomes 2 to the 3rd times 0, because the cosine of 3 pi over 2 is 0, plus -I, because sine is -1 there at 3 pi over 2. And so then we end up with 8 times 0, which is just 0, and then 8 times -I, which is -8I. All right, and we will take a look at the last few examples in class together.